We are back with skills from first year chemistry 102, and this is part 2 of 2. And what we're talking about right now is the stoichiometry map that you saw last year. And I just want to go ahead and get that down, and then we'll do an example problem. So with any stoichiometry problems, at the heart of any stoichiometry problem is always a moles to moles calculation. So I'm just going to draw you a little map here. And the map is going to start off with 2 boxes, one on the left, one on the right, and an arrow between them. And this would be considered like a point that you could be at in a problem. So you could start off with moles of a known substance. So we call that moles known. And if we wanted to get to the moles of the substance that is not known to us or that's asked about, we would call that the moles of the unknown. And to get between them, we multiply by the mole ratio. And we talked about mole ratios in part 1. And the mole ratio that you would use is always going to be the coefficient to the known substance on bottom and the coefficient to the unknown substance on top. So remember, these represent coefficients. And we'll do an example so you can see what I'm talking about there. So if I want to get from moles of the known substance to the moles of the unknown substance, I multiply by a mole ratio. Okay, we are not always given moles, so we have to be prepared to deal with if we're given, instead of moles of a substance, if we're given grams of a substance. So if we're given grams, then we're going to do a step before the mole ratio, and that is to convert from grams to moles. And the way we're going to do that is just use an equivalence, 1 mole, and that's going to be over the molar mass of the known substance. So you're chaining together some different equivalents to answer a given stoichiometry problem. Now, if you're asked to answer in grams, say, what you're going to do is multiply by another equivalence, and you'll have 1 mole on the bottom, and then this is going to be the molar mass of the unknown substance. So this is the substance that you're being asked to answer about. So that's a really basic roadmap to sort of assist you with stoichiometry problems. And I always tell my students to think at its heart is a moles to moles calculation. Every stoichiometry question has a moles to moles calculation in it. So you can think of this, the moles to moles. I'm just covering up the grams parts with my hand. You think of the moles to moles as your really basic step. There's always a moles to moles. Now what if you're asked for grams and you're given moles? Then you would add that step on. So you would have a mole ratio and a molar mass. If you're given grams and asked for moles, then you would do this. So you'd start with grams and do 2 steps. And if you're given grams and asked for grams, then you're going to do the whole thing, which would involve 1, 2, 3 steps. Okay, so let's go ahead and do an example. We'll go back to the combustion problem, or the combustion reaction. So this is going to be our example. We'll have C2H6 plus O2 making CO2 plus H2O. And we remember our coefficients here, 2, 7, 4, 6. And let's say as an example, if 15 grams of O2 are reacted as above, how many grams of CO2 could be produced? So what we want to remember is that we have a map to help us, and what we have to identify is what am I starting at and what am I ending at. As with any adventure or trip, we have to know where we're starting and know where we're ending. So we are given grams of oxygen, and so this is going to be where we start. This is our starting point, and we are asked to answer in grams of CO2. So we need to get over here to grams of CO2. So our oxygen, this is our known substance, and the CO2 is our unknown. So what we're going to do is start with our 15 grams of O2.
15 grams.
15 grams. And we're going to do this step where we do multiplied by 1 mole over the molar mass of the known substance. And I am going to assume at this point that you know how to calculate molar masses. And so you would add up 2 oxygens together, and you would find that the molar mass of the oxygen is 31.998. So we want to indicate that that's 1 mole of oxygen. Okay, so our next step is going to be to do the mole ratio. And remember, the mole ratio is the unknown coefficient on top and the known coefficients on the bottom. So we have identified the oxygen as our known substance. So we're going to go to the balanced equation and find the coefficient for the oxygen is 7. And the unknown substance, the substance that we're asked to answer about, is CO2. So that's going to be a 4 on top there. So there's our mole ratio. It's unknown over known. Okay, now we're asked to answer in grams. So we're going to do one more step in which we convert to grams using the molar mass of CO2, which is our unknown substance. And if you add together 1 carbon and 2 oxygens, you will end up with this molar mass, 44.009. Okay, so we break out our trusty calculator, and we are going to multiply together everything that's on the top of these expressions, and the beginning number is considered a top number. So in our calculator, we would go 15.0 times 1, which obviously doesn't make a difference in the math, and then times 4, and then times the molar mass, 44.009. Oops. And then I'm going to divide by 31.998 and divide by 7. And for my answer, I will get 11 point, how many sig figs? I have 3 sig figs, so 11.8 grams of CO2. Okay, so that's a basic grams to grams calculation using the Stoichiometry Map. So post questions in the comments if you have any.